Hi, Math 30s. We're moving on to lesson 5 in your workbook, and lesson 5 is on page 531. This is the lesson where we are going to finish constructing the unit circle. So we've already constructed the unit circle in radians and in degrees, and now we're going to put the points on the unit circle. I'm going to do this lesson in about 2 to 3 podcasts, so 2 to 3 videos I'll make. And how I always start is I'm going to start with a review of special triangles. And you need this handout. So there should be a 2-page handout that you would have gotten in class, or I will upload blank copies on the classroom. So before we start with actually labeling the unit circle, you need to understand special triangles. And in 20-1, there was 2 special triangles that we introduced you to. So the 2 special triangles were the 45, 90-degree special triangle, so it was an isosceles triangle. And then the second special triangle was a 30, 60, 90 degree. Okay, there's a counting system that I use in order to do these special triangles, and you have to sort of just, if you remember this counting system, you will be able to create the special triangles. If you could create the special triangles, you'll be able to generate the unit circle. So what I want you to remember for the 45, 45, 90-degree special triangle, so the isosceles, is 1, 1, root 2. Okay? And if you check on your calculator, the square root of 2 is 1.41. So I'm just going to write that. Square root of 2 is approximately equal to 1.41. Okay, so how does this work? What I have on my Cartesian plane is I have a 45-degree isosceles triangle. So this would be your right angle. This is a 45-degree angle, and this is a 45-degree angle, right? All 3 angles add up to 180. Across from each 45-degree side, or each 45-degree angle is a side, and these are going to be of equal length. They get side length of 1 unit. So I would say, okay, this is 1 unit, and this is 1 unit. Then across from the 90-degree angle is your hypotenuse. That's the longest side. And between a 1, and a 1.41, the longest side is 1.41, which is root 2. Okay, from here, this was good enough for Math 20-1, but in Math 30-1, what we want is we want the radius of our unit circle. So this is eventually going to be our radius, and we could spin this around the Cartesian plane. We want this radius to be of length 1. Okay, so that's critical for creating the unit circle. The radius is always length 1. So I need to make this into a 1, and how you do that is you're going to divide this by root 2. But if you divide one side of your triangle by root 2, you have to divide every single side by root 2. So now essentially what I've created is I've created a triangle, 45-degree triangle with a radius of 1, and my x length is 1 over root 2, and my y length is 1 over root 2. However, the last thing we have to remember before we could finish off with our 45-degree special triangle is we need to rationalize the denominator. So we have to get rid of this root 2. So in order to get rid of the root 2, I need to multiply numerator and denominator by root 2. And what you would get is you would get root 2 over 2 and root 2 over 2. So I'm going to now just erase this to clean this up. And now my x length is root 2 over 2, and my y length is root 2 over 2. And that's how you generate the x and y coordinates on a 45-degree triangle. And what's eventually going to happen is I'm going to say, okay, what is this point on the unit circle? So that point is the x value. So what's this x value? And that x value is root 2 over 2. What's the y value? Root 2 over 2. So for all of our 45-degree angles, these are our coordinates. This is how we constructed the coordinates so you have an understanding. But I often tell students, if you can just remember for the 45-degree special triangle that it's root 2 over 2, you will be good. So here's what I mean. We're going to take that coordinate. So this is how we constructed it, right? You don't need to know how we constructed it. I just want you to have an understanding. But let's take this and put it on our unit circle now. So here's my unit circle with all the 45-degree angles, right? So if we were to label these according to, let's do our radians in here first. So our radians would be, remember our radians are all over 4. This is pi over 4. This guy is 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, 8 pi over 4, which reduces to 2 pi. Okay, the only one I'm going to clean up, what am I doing over here? Sorry, this should be over 4. 2 pi over 4 reduces to pi over 2, so let's clean that guy up. Okay, so once you have your radians in at your 45-degree angles, right? So these are all 45s. What we could now do is put in our point. So we just calculated that we know that this is a 45-degree angle, right? So these are all my 45s. These guys here are all 45s. And we know that the point now is root 2 over 2, root 2 over 2. So go in and put that point at all 45-degree angles. The last thing you need to do once you get all your root 2 over 2 in, because both x and y for a 45-degree angle are going to be root 2 over 2, we now need to figure out the positives and negatives. So in quadrant 1 here, both x and y are positive, right? In quadrant 2, if I said, imagine like this is your triangle here, what is this x coordinate in quadrant 2? X is negative, so I've got to put a negative here. And in quadrant 2, y is positive. In quadrant 3, so this would be my triangle, right? That would be my reference angle there. That's a 45-degree angle. In this quadrant here, x is negative and y is negative. So if I said, well, what's this y value? You would say, okay, that y value is root 2 over 2, but it's negative root 2 over 2. So in this quadrant, both x and y's are negative. And then in quadrant 4, so here's my triangle in quadrant 4, right? That's my 45-degree special triangle right there. And in quadrant 4, x is positive, right? So this x value, root 2 over 2, is positive, but y is negative in that quadrant. So let's see if we've got everything done. And then here would be your triangle in quadrant 1. Okay, so we just did all of the 45-degree special triangles. Now let's take care of the 30s. So again, remember your unit circle, it's divided into 2 different types of triangles. It's either a 45, 45, 90, so it's going to be the isosceles here, or it's a 30, 60, 90-degree triangle. So the counting system that you have to memorize for 30, 60, 90, I always tell students it's going to be 1, 2, root 3. So if you can remember 1, 2, root 3, you'll remember this counting system. We need to find out what the square root of 3 is. So the square root of 3 is 1.73. So I'm going to write that down. So approximately equal to 1.73. Okay, so how this counting system works is we know where the 90-degree goes. It goes right there. And I'm always going to put my 30, we're going to start with 30. So I'm going to put my 30 as my rotational angle. So that would be a 30-degree angle. And then by default, this guy would be the 60. Now I have to figure out, okay, where does the 1, where does the 2, where does the root 3 go? The smallest side is the smallest number. So between a 1, a 2, and a 1.73, 1 is the smallest length, and that's going to go across from the smallest angle, which is 30 degrees. So across from the 30 degrees, the 1 goes there. Then on the hypotenuse, I need to put the bigger side. So what's bigger between a 2 and a root 3? The 2 would go here, and the root 3 would go here. So the 2 would go there, and the root 3 would go there. Then we have to do exactly what we did in this triangle. We need to get a radius always of 1. So I need to get rid of that 2. So I'm going to divide everything by 2 because I want a radius of 1. So 2 divided by 2 is 1, so I'm good there. So that's 1. And then these sides are also done because the reason why these guys are done is they're rationalized, right? As long as I don't have a radical in the denominator, I am totally fine. So now what I'm going to do is I'm going to say, okay, well, what would this point be? What is the x and the y coordinate at that point? Well, the x coordinate is this length here, and this length here is root 3 over 2. And the y length up here is 1/2. So that is going to be all of your points. That's going to be your coordinate for your 30-degree angles. It's going to be root 3 over 2, 1 over 2. So again, this is how we construct it. So if ever you sort of forget these numbers and you freeze on a test, you're going to have to construct a 30, 60, 90-degree angle and say, like, what were those 2 points? But now let's put these points on our unit circle. So now we're going to do the 30 degrees, okay? So the 30-degree unit circle, eventually we're going to add it all together, but these we're dealing with the 30 degrees. And remember that this is over 6. So if I was dealing with over 6, let's do our counting system. So this is pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, down here, 7 pi over 6, 8 pi over 6, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, so we're going to have to reduce some of these, 11 pi over 6, and 12 pi over 6, which is 2 pi. Okay, so the 30-degree angles, you guys, are this guy, this guy, this guy, and this guy, right? Those are my 30 degrees. So what we're going to put at each 30-degree angle, so the lines for the 30-degree triangles, it would be like there's a 30-degree triangle, there's a 30-degree triangle, there's a 30-degree triangle, and here. Okay, so at these 4 points, after you do your 45s, you go and you label these 30s. So we just calculated that a 30 is root 3 over 2 and 1/2. So what I do is I literally go to every single 30 and I put that same coordinate in. So every single coordinate I would go to and I would put that in. Once I have that done, I now go put in my negatives and I say, okay, which were the negative coordinates? So I know in quadrant 1, both are positive. In quadrant 2, the x's are negative in quadrant 2 and the y's are positive. So that guy would be negative. In quadrant 3, both x and y are negative, right? So both x and y in quadrant 3, and in quadrant 4, only y is negative. Okay, so we are almost done. We have to now do our 60 degrees. So a couple of things. Initially, I had told you, and it's not incorrect, but I had told you that these are 30 degrees as well, right? Those are 30 degrees. And I use that when we're figuring out like our degrees on our unit circle. So we know that this is 90 degrees. And this point here would be 90 minus 30, which is 60 degrees. So this point here, 2 pi over 6, which is equivalent to pi over 3. So I'm just going to write pi over 3. That is equal to 60 degrees. So when I say, well, what's 60 degrees? This triangle here now is a 60-degree triangle. So this is 60 degrees. And then this triangle here is also 60 degrees. So that's 60 degrees, and how we would get this one in degrees is if this is 30, this slice of the pie is 30, 90 plus 30, that would be 120 degrees. So 4 pi over 6, which reduces to 2 pi over 3, that would be 120 degrees. But this is, the triangle itself is a 60 degree. This guy, and I'll do it in purple, is a 60-degree triangle. So this one here is 60 degrees, as is this guy. From here to here, this is 60 degrees as well. Okay, so to finish this off, let's find on our special triangle where the 60 degrees are. So I'm just going to go back to the special triangles. So what I'm going to do now is instead of putting 30 degrees here, I'm going to put 60 degrees here. And I'll show you what happens. So 60 degrees, 30 degrees, 90 degrees. We still have to do that counting system 1, 2, root 3. Across from the smallest angle goes the smallest side, which is going to be 1. So 1 goes there. The hypotenuse is always the biggest number, which is going to be 2, and then root 3 would go here. We need to get our radius of 1, so we're going to divide this by 2, this by 2, and this by 2. Now we have a radius of 1. And now I could figure out this point. So this point here, the x-coordinate is 1 over 2, and the y-coordinate is root 3 over 2. So we're going to transfer that to our 60-degree triangles now on the unit circle, but you're going to see something really interesting. So when I go back to the unit circle and I get to my 60 degrees, so I've got this guy to do, this guy, and this guy. We're going to put in those points, which were 1 over 2, root 3 over 2. So let's put all of those points in, and then I'll show you what you could notice that is going to help out. 1 over 2, root 3 over 2. Let's go down here. 1 over 2, root 3 over 2. And down here, 1 over 2, root 3 over 2. Okay, let's put in our negatives, and then I'll talk about a little trick that some of you will have seen. So quadrant 1, both x and y are positive. Quadrant 2, x is negative, so I've got to put a negative there. Quadrant 3, both x and y are negative, so put a negative in for both of those. And quadrant 4, only y is negative. What the last sort of trick that I wanted you to see is as follows. If you look at the 60-degree special triangle, it is actually the exact opposite of the 30 degree. So this 30 degree is root 3 over 2, 1 over 2. The 60 degree, these coordinates are just reversed. So what I often tell students is don't even bother with memorizing, like thinking about this guy. If you could do your 45-degree special triangle, you put all your 45s in. Then jump to your 30 degrees and say to yourself, okay, 30 degrees, I know that 30 degrees is root 3 over 2, 1 over 2. Go and put all 4 of your 30 degrees in. Then from there, do all of your 60s last. And just tell yourself 60 is the reverse of 30, right? If 30 is root 3 over 2, 1 over 2, 60 is the opposite of that. Okay, before we finish this video, we have one last quick thing to talk about, And that is all of the coordinates at the axes. So I actually generally like to start with this before I do everything else. So that's these 4 coordinates here we need to know. And these 4 coordinates here, it has to do with this radius. In our unit circle, our radius is always going to be 1, right? The radius is always going to be 1. This guy is my radius, it's going to be 1. So if I said, well, what's the x and the y coordinate? The x coordinate here, I'm going to 1, and the y coordinate, I'm not going up at all. So it's 0. Over here, on the y-axis, my x value is 0, and my y is now where my radius is. This is my y, and my radius is 1. Go over here, and this is a value of 1, right? So that's my x value. My y value is 0, but that is actually going to be, because we're going like this would be in the negative direction. So I would actually say that this is -1. And then down here, my radius is still 1. So my x value is 0, and my y is now -1. So this is how you would put the 4 coordinates that exist on the axes.